New topic is functions. Today we're looking at functions and relations. So, what is a relation? We're going to look at what a relation is and what a function is. So, a relation is just a set of inputs and outputs, often written as an ordered pair. You know, like an example is here, 0, -2, 0, 1, just a set of points. For this x value, there's that y value, okay? We can represent a relation, you know, you can graph it here. You can represent it as a mapping diagram. I don't know what this is. That's a mapping diagram, all right? Or a graph or an equation or something like that, all right? So we're going to look at a few different types. Here's a mapping diagram, here's a graph, and here are equations down here, all right? So these are relations. Now, everything, pretty much, if you've got an x and a y value or an input and an output, it's a relation, but not every relation is a function, which we're going to discover on the next page. Okay, now, here is an example of a relation. See, 0, -2, 0, 1, 1, 2, see, 2, 1, 3, 4. Or I could have graphed them here. I've got 0, 1, 0, -2's down there. Can you see? I could either do that like this input output, I could graph it, all right? They're just relations. But others are, so all those points are graphed here as well. So they're relations. So, but other examples are these. Now, in this topic, we are going to learn how to draw all these. So the first one, y = x squared. What's this? Parabola, concave up. All right, so that's a parabola with vertex at the origin. I'm not going to worry about other points, okay? Really, if I do want to sketch that, I really should be showing one other point. So I will, when x is 1, what's y? When x is 1, y is 1. Y = x cubed. Do you remember what these look like? Cubic. It's the squiggly this way. And if you're not sure, when x is 1, 1 cubed is 1, 1, 1. But when x is -1, -1 cubed is -1 as well. So that's y = x cubed. X squared plus y squared is 9. Do you remember what this is? A what? Circle, center 0, 0, radius. See, that's really x squared plus y squared is 3. Look, we will be spending lessons on each of these, okay? That's just a circle, radius 3. So these are all examples of relations, okay? Some of them are functions, some of them are not. We'll look at that on the next page. Do you remember what the next one is? Y = 2 to the power of x. Let's just substitute some values if you're not sure. So, x is 0, what's y? 1. When x is 1, what's y? 2. When x is 2, y is 4. It does become quite steep. When x is 1, y is 2. So I'm just putting a few points on there. What about when x is -1? What's 2 to the power of -1 mean? 1 over 2. It's a half. 2 to the power of -2 is a quarter. This graph looks like this. Okay, that's an exponential curve. Okay, so we've got parabola, cubic, circle, exponential. Look at this y = x squared and look at this x = y squared. That's just a sideways parabola. So I'm just going to choose some values. When x is 0, wouldn't y be 0? I'm actually going to choose y values first. What about when y is +1? What's x? When y is +1, x is? When y is 1, 1 squared is 1. So when y is 1, x is 1, so that's the point 1, 1. What about when y is -1? So I've got the point when x is 1, y is 1, but we did when y was -1. -1 squared is 1, x is 1. So I've also got x is 1, y is -1. This is actually a sideways parabola, but look, we do a whole topic on drawing parabolas, all right? So that's x = y squared. It's like y = x squared. You know where the x is, the y should be, and where the y is, the x should be from what you're used to? I'm going to turn the page. All right. So it really is just x's and y's sort of swapped. All right. And this is what we call a stepwise function. But see, when x is 3, the y value is down here. It's not up there. It's a step function. Okay, now these are all different types. Sorry, function. It's a relation. Now, we're going to determine whether these are functions or not as well. So these are all examples of relations. You know, you can have points joined together or points on their own. Do you know what I mean? Or input, output. Now, let's look at what a function is. So, a function is a relation in which each input has only one output. So, are we okay with that? So, you know those original points that we looked at when, over the first page, we did have those sets of points and they were graphed on a line, or on the number plane, sorry. And we had these points shown with input, output. Do you remember those on the page before? Well, a function is a relation in which each input has only one output. A function is defined as a set of ordered pairs x, y with a special property that every x value has only one y value. Now let's look at this relation. 0, -2, 0, 1. The value x is 0 has two y values. Do you get it? 1, 2, 2, 1, 3, 4. Is this a function or not? A function is a relation, so everything's a relation, but only certain relations are functions. For it to be a function, each x value has only one y value. Now, because of this, it's not a function. So, it is not a function. In other words, it's still a relation. It's a relation, but not a function, because the value of x equals 0 has, or it's because, x equals 0 has two corresponding y values of -2 and 1. So when you look at x is 0, there are two corresponding y values. Now, if I look at, all right, we'll look at that in a minute. What about y equals x squared? I'm going to look at the graphs. All right, so, you know, I'm going to highlight here, these were the 2 points that were the problem. Do you see that? In our first one. The problem was 0, -2, and 0, 1. The others aren't a problem, right? Y equals x squared. If you look at every value of x, when x is 1, y is 1. When x is 2, y is 4. It's not negative. When x is -1, y is 1. When x is -2, y is 4. Do you think each x value has only one y value? It does. Because if I try and work it out, but let's look at this parabola down here. When x is 1, what does y equal? 1 or -1. This is not a function. Okay? Let's look at my circle. When x is 0, what does y equal? 3. This is the point, you know, this is the point 0, 3. And isn't this the point down here on the circle 0, -3? This is a problem. This point 1 has got two y values as well. When x is 1, I've got two y values. When x is 2, I've also got two y values. This is not a function. This is not, so that's not a function. This is not a function. Can you see? The parabola is a function. Because can you see when x is 1, you've got two y values? When x is 1, there are two y values. Like, for example, when x is 0, y is 3 or -3. But this is a function. This is, yes, function. Every x value has only one y value. X value has only one y value. All right? Same with this one. When x is 1, y is 1. When x is 2, y is 8. This is a function. One y value for each x value. Same reason. Every x has only one y. All right? Every x has only one y value. Same with this. You try it when x is 0, y is 1. This one's a function. Right? Now, we're going to learn a quicker way of doing it than looking at all this. Same with this one. You might be debated about the point x is 3. When x is 3, what value does the function hold? Is it down here or up there? Is 3 included on the top line? No. So this is a function. Every x value has only one y value. All right. Now, instead of looking at it like that, it's much easier to look at it another way. All right? And what we're going to do, the two that weren't a function, the circle and the sideways parabola, I can draw lines, vertical lines through these, and it cuts the curve twice. Why do you draw vertical lines? Because x values, you know, if I draw the line x is -2, that's here, x is 0, x is 1, that's why you draw a vertical line, because you'll see if you do get two y values on the graph. Not a horizontal line, a vertical line. Look, with the circle, you draw a vertical line, you cut the graph twice in many places. But the parabola, you draw vertical lines, you only cut it once. Same with the cubic, same with the exponential, same with my step graph. Okay? So, that brings us to the vertical line test. Now, we said that, sorry, and I wrote all the answers to this on the page before. Are you okay with that? The relation, the parabola is a function. Why? Because every x value, I'm not going to write these, every x value has only one y value. The circle is not a function. Do you get it? The x values have more than one y, have two. Well, most of the x values have two y values, except there are 2 points that don't. Do you know what they are? The 3 and the -3. So most of the x values have two y values. And 5 to the power of x, the exponential, is a function, because every x value has only one y value. Okay, now instead of doing that, all you do is look at the function, and if you can draw a vertical line and cut the curve only once, it's a function. If you draw a vertical line and you cut the function twice, it means for that particular x value, you've got two y values. So let's have a look. So instead of saying all this, the vertical line test drawn through a function should cut a function only once, since for a function, every x value has only one y value. Here is a concave down parabola. I keep drawing vertical lines, and you know, this vertical line only cuts the function at this cross. This vertical line only cuts it there. So this is a function. This one, this relation, they're both relations, but this is not a function. Because we can see for this x value here, you've got two y values. For this x value, I've got two y values. Do you see? Yeah? All right, let's keep going. For the graph in one color, y equals x squared. Do your vertical line test in another color. Y equals x cubed, good practice. And you can do your vertical line test in another color. And yes, this is a function, etc. Do you want to do those? We've just sketched those same graphs before. Yep, function. Are we good? Give you a few minutes. The parabola is a function. The cubic is a function because it passes the vertical line test. The circle is not a function. It fails the vertical line test. The exponential is a function, passes. The sideways parabola is not a function because it fails the vertical line test. And the stepwise graph is a function because even when x is 3, the value of y is on the lower graph, not the upper graph. Okay? Looking at function notation, if y depends on what value we give x in a function, then we can say that y is a function of x. So whenever you see a graph like an equation like this, y equals x squared plus 2x minus 3, see y, the value that we find for y depends on what value we give x. See, when x is 1, I get a y value. When x is 2, I get a y value. So what we say is that y is a function of x. Now the way we write that is f for function, y equals function bracket x. Okay? So just some examples from exercise 5.2 in your textbook. So if y equals function of x, then you can substitute any value. Function of a is the value of y at the point when x is a. See how the a replaces the x? So for example, function of -3, if function of x is that, I just go function of -3. It's telling me replace the x with a -3. Do you see that? So all I do, that's my function of x. I just start writing it out again. Every time I get to an x, I replace the x with a -3. 2 times -27, that's -54, plus 15, plus 4, whatever you get. negative 35. Now, if y is a function of x. So instead of seeing y equals whatever, you're going to see function of x equals. Okay? Now in the next one, question 7, if function of x is x squared plus 3, find any values of x for which function of x is 28. So we replace this fx with 28 equals x squared plus 3. And then we just solve. What do you think we've got? X squared is 25. All good? And x is plus or minus the square root of 25. Don't forget that, which is plus or minus 5. Now, all good? Question 11. Now, it doesn't have to be function of x. It could be the g of x or the h of x or the... Okay, it doesn't matter. Instead of having f for function, they've got g of x is x squared plus 2x plus 3. So now I just replace my x. I have to find g of x minus 1. I just replace my x, replace the whole x with x minus 1. So wherever there was an x, there is now an x minus 1. So we've got g of x minus 1 is x minus squared plus 2 times x minus 1 in brackets plus 3, which is x squared minus 2x plus 1 plus 2x minus 2 plus 3, which is x squared, the 2x's go, plus 2, I think. Okay. Question 14. Given that the function of t equals t to the power of 4 plus t squared minus 5, find the value of function of b minus the function of negative b. If you want, you can just write out function of b first. In other words, I'm replacing. So I know function of t is that. Function of b just says to me replace the t with a b. Wherever the t was is now a b. So isn't that b to the power of 4 plus b squared minus 5? Don't worry about minus function of negative b. Let's just do the function of negative b. What's that telling me? Wherever the t was, replace it with a negative b. Negative b to the power of 4 plus negative b squared minus 5. What do you get? What's a negative times a negative times a negative times a negative? It's a positive. Any even power of a negative is a positive. Plus negative times a negative is a positive. And what do you think the answer is going to be? So therefore, the function of b minus the function of negative b, you write out what your function of b is. So this is good setting out. B to the power of 4 plus b squared minus 5, take away in brackets what your function of negative b is. Take away b to the power of 4 plus b squared minus 5. If you want, you can expand your brackets, but you should be able to see if I do function of b minus function of negative b, I'm just going to get 0. That, take away b to the power of 4, take away b squared plus 5, well, they all cancel out and you get 0. Now this doesn't always happen. That won't always happen if you do function of b minus function of negative b. It'll only happen for certain types of functions. So function of 3 minus function of 2 plus 2 times the function of negative 3 when this function is defined by these 3 things. Now we are going to be drawing these at one stage. I'll see, we might draw it this lesson. We might. It's no big deal. All right. All right, function of 3. Where's that going to sit? Do you think you'll go with the equation up the top, the equation in the middle, or the equation down the bottom? When x is 3, I'm going to go function of 3 equals x for values of x greater than 2. Now 3 is greater than 2, so the function of x equals x for values of x greater than 2. So the function of 3 equals 3. X, but x is 3 in this case. Let's do the function of 2. Tell me which row you're working on, top, middle, bottom. Function of 2, when x is 2. See, function of x, when x is 2, aren't I in the middle? So isn't the function I use is 2 squared, yep, is 4. Good. And the function of, I'm actually going to do 2 times the function of negative 3, okay? Or will I just do the function of negative 3? It doesn't matter. I'll just do the function of negative 3 for now. Don't worry about 2 times. Function of -3. Just be careful which one are you going to use. And there's no substitution, it's just 4. Now I'm going to draw it for you in a minute, I've decided. So therefore, the function of 3 minus the function of 2 plus 2 times the function of -3 is 3 minus 4 plus 2 times 4. Do you get it? So I worked out each one separately. First one's 3, the second one's 4, and we're going to do the first one minus the second one plus 2 times the last one, which is 3 minus -1 plus 8 positive 7. Teaching this later, but I want to do it now. So we're just looking at values greater than, from more than 2 to less than 2. I'm going to go 1, 2, 3, 4. -1, -2, -3, -4. And let's just start substituting for values of x greater than 2, so it doesn't include 2. So I'm going to put a circle. What about when x actually equals 2? Let's look at this one. When x is 2, didn't we get 4? When x is 2, what do you get? 4, don't you? What about when x is 1, positive 1? What do you get? You'd use here. What do you get? When x is 1, it fits in here. 1 squared is 1. Oopsie, wrong, down here. What about when x is 0? What do you get? When x is 0? 0. Good. X is -1? You get 1. It's a parabola. Remember I said it was a parabola? X is -2, you get y is 4. Now I'm going to circle that in because these are definite. I know I drew that little dot there in the wrong place. See? I have a parabola. This is telling me I have a parabola for values of x lying between -2 and 2. So I'm just going to draw my parabola only between -2 and 2. All right, let's do this bottom one. Y equals 4 for values of x less than -2. So this graph, isn't this 4 already? Just like this. That's the line. You know the line y equals 4 goes like that, but it's only for values of x less than -2. I know I don't have an open circle there, but the closed circle belongs to the parabola, and this is a point of discontinuity anyway. See how the curve is not smooth and continuous anymore? It takes a sharp turn. I've got discontinuity there anyway. And for values of x greater than 2, so give me a value. Tell me a value of x greater than 2. When x is 3, your equation is y equals x. So when x is 3, what does y equal? Function of x equals x means y equals x. So when x is 3, y is 3. When x is 3, y is 3. When x is 4, oh my goodness. What about when x is 2? But it's not included, right? So I have to put a circle. When x is 5, y is 5. All right, you know what it is? It's a straight line, but I'm not allowed to include the point x is 2. But I can go like to 2.1 or 2.01. So I'll put a circle around the 2. Okay? And that's, yeah, that's a break. The discontinuity in the function. Okay, so that's what the curve looks like. We'll be practicing drawing those later anyway, but that's it. Question 22. Simplify this. Function of x plus h minus function of x over h. You know what we do? We do it in small steps. Let's just work out, that's function of x. Function of x plus h. What's the instruction? Replace x with what? X plus h. Function of x is that. If function of x is that, function of x plus h says to you, wherever you see an x, you now put an x plus h. So you use this function to bracket, instead of writing x, I write x plus h squared, plus, instead of writing x, I write x plus h. Are we okay with that? If it was function of 3, I'd replace my x's with 3. If it's function of, I don't know, x squared plus 3, I replace my x's with x squared plus 3. Now, I've got 2. What are you going to do now? plus x squared plus 2xh plus h squared plus x plus h. Then I'm going to expand. 2x squared plus 4xh plus 2h squared plus x plus h. And what do we get? Just that. You can't simplify it. No other x squareds, x's or h's. And that's that. Now, that's what function of x plus h is. Now we know what function of x is, we know what function of x plus h is. So therefore, function of x plus h minus the function of x over h equals, I write this out, that's my function of x plus h, it's 2x squared plus 4xh plus 2h squared plus x plus h minus what? Yeah, but do you want to use brackets or can we go minus that, minus that? So because you're going minus, and if that was a bracket, that would be plus x, but I have to put brackets, and on the next line I'm going to put minus x. Do you want the brackets? I'll just go brackets over h. So now that's 2x squared plus 4xh plus 2h squared plus x plus h. As you get more confident, you could just go straight to this line. Minus 2x squared minus x, you know, over h. What cancels? 2x squareds. The x's cancel. Is that it? So I've got 4xh plus 2h squared plus h over h. You know, I can simplify that. You can factorize out a h from the numerator and cancel it with the h from the denominator, or you just divide everything through by h. Oops, plus 1, isn't it? And then the h's cancel. So just be careful. I've got 4x plus 2h plus 1 over h. The h's cancel and it's 4x plus 2h plus 1. Now, you will use this at the end of year 11 more when we do something called differentiation from first principles. So that's where you will see it again. Not now. 5. Function of x is defined by 3 different functions depending on the values of x. When x is greater than or equal to 3, we have a cubic. When x lies between 0 and 3 but not including 0 or 3, this is like y equals 5, which is a horizontal line. And when x is 0 or negative values, you have a parabola, concave up or down. Concave up, and if you factorized it, you could work out where it cut the x-axis, right? So it's drawable, but the problem is the first value for the cubic is what? What's 3 cubed? 27, so big values, we don't want to be drawing that. So let's work out each of these. Function of 0 for part A. Do you know which one you're going to use? Be careful. It's not the middle one. It's when x, so we have to use x squared minus x plus 2, so it's 0 squared minus 0 plus 2. I replace my x with a 0. And what do I get? Good. Now we want the function of 2 minus the function of 1. Maybe we'll do this one in one step. Function of 2, which one? The middle, which is just 5. See, the middle one its value doesn't change depending on x. It's always 5. Take away, which one's the function of 1? Middle. 5 minus 5, which is 0. And C, the function of negative n squared. Now you might say, I don't know what n is, but is it positive or negative? It's negative because it's negative. Even if n was negative 2, it's negative. Negative 2 squared is 4. It's negative. Look, watching. N squared is always positive. And then you throw a negative out the front. Okay? So this one will always have a negative value no matter what. If n is positive, I still get a negative. If n is negative, like negative 2 squared is 4, and then I throw a negative in front of it, that's negative 4. So this is always negative, so it's got to be the last one. So I'm going to say this is always negative. So it's the last one, or it could be 0, right? So I replace the x squared every time I see it with negative n squared. Sorry, no, I replace the x with negative n squared. So I go negative n squared squared. Are you okay with that? Replace the x with negative n squared minus, in brackets, negative n squared plus 2. What have you got? No, a negative times a negative now is a positive. And n squared to the power of 2 is n to the power of 4. A negative times a negative. This is negative n squared times negative n squared. What about the next one? Plus n squared plus 2.